Okay, so we're back having done, the DC is all wired up. I've been using the little tie downs, little zip ties to bundle all the cable together to create a nice rigid sort of system that's self-supporting. I've started in on doing the audio path on the interface, the input interface, which will loop in the flanger and the phaser. And I'm going to continue doing that right now. Pulling out one of these plugs to do so. I also wanted to show you, sometimes a visual is always more helpful, a comparison, but I wanted to show you the difference between like our solderless type of connector versus, let's say, a pre-made high-end cable. Now I got this high-end cable here when I purchased a pretty expensive piece of gear, and it was given complimentary as sort of a thank you for buying it. And this is really, you know, a good stuff right here. I see a lot of people using it. But if I put these two connectors next to one another, right, you can see that you really have about maybe ½ an inch more of a jack here sticking out this way. That, in my opinion, is sort of valuable real estate when you're trying to nest your pedals to. If you've got 1, 2, 3, 4, 5 pedals, each one of those has a gap, 1, 2, 3, 4 gaps. And you're adding another ½ an inch right there. You're talking about you're missing 2 inches, right? That could be the difference between fitting a pedal on your board versus having to get a bigger board. So for me, this is the only way to go. And the cable too, being it formable and being, you know, of a very low noise, low capacitance, great sounding stuff. I'm glad that I have it, even though we came up with it. I'm glad that I have it because it's sort of what I wanted to have. And if you guys appreciate it too, then you guys can get it and go along too. But really, I mean, we made it for, really like everything else that we've ever made at Three Monkeys, it was made for us. All right, we wanted to make something that we liked, or that Brad liked, or Greg liked, I liked. And then if someone else appreciates it, that's great. But we kind of wanted to do what we wanted to do. And then when we saw the need for making this stuff, it was like, you know, we wanted a different way of wiring up our pedal boards. So we came up with this. So anyway, I'm doing the loop here for the input and output of the phase 90. So we have our send right here. So it'll go to the input of the phase 90. So I'm just going to measure it off. It's tough to get in there. So I'm using a little flathead screwdriver to help me pull these out. Because in a tight space, it's hard to get a grip on them as they're such small connectors. But when it's, you know, you could get them out as long as the space isn't too tight with just your fingers. But if you have a problem, you can always just use a little screwdriver and just pop them out. All right, so I've got this cable on one side and cut to length, and I'm going to go ahead and screw on the other side. There we go. All right, and you can also, you know, you may have noticed just there that there's this U channel cut into the side of the plug here, which allows you to bend the cable into there, and you really get then a ridiculously low profile, right? There's nothing on the end there. So we could actually make these smaller, but then you really can't get a grip on them. It becomes ridiculous. And if you wanted to use the screwdriver, I guess we could have done it that way, but you know, we figured this was cool. So I'm going to go ahead and put this in, tuck it underneath, and fit it into the input of the phaser, and then run that like so in underneath. Bend the cable to the shape I want, and it'll stay there. There we go. All right, so that's the send right there. And now we're going to do the return, which we're going to go over the top of it. So I take out this plug. See, I got that one because I got a little room, more room there to stick my hand in. Go ahead and screw this on. And I think some people have asked about what's the possibility of these unscrewing. And well, there's two reasons why they wouldn't unscrew. There's a lot of friction, number one, keeping them on. Number two is the fact that the two ends are sort of opposite of each other in a sense. Let me just demonstrate something for you real quick. So in order for, let's say, the the plug itself to back out, and I'm just going to go ahead and screw on a couple more ends here real quick, just as an example so I can show you. Now, clockwise is tight, right? But longitudinally, when you're looking at it, clockwise is the different way when looked at it from this way, right? So in order to tighten both ends, they're going counter to one another, right? So I'm tightening both right now, and it's going counter. This one's going this way, this one's going this way, right? So counterclockwise, clockwise. And the thing is too, for it to unscrew, now basically for one to unscrew, the other one has to get tighter. Does that make sense to you? So if you've bottomed out the plug and you've tightened it upright, it can't, because it has to turn. And for it to turn, it would have to go further into this way, and it can't. So it can't unscrew. So that's how it sort of works. It's what you call like an elegant solution in engineering, where it takes care of itself for some reason. It just has a property that allows it to take care of a problem just by its own virtue. So it's an interesting thing. But also too, the U channel helps as well, because obviously it can't turn anymore, right? Once it's stuck in a U channel. But really the cable is what's holding the whole sort of schlemiel. That's my favorite word ever, the whole schlemiel together. Must be from being from New York. But it was, what was it? Laverne and Shirley used to say schlemiel and schlemazel, but they didn't come up with it. And they were in Milwaukee. All right, so I'm just going to do this last cable for you, and then I'm going to cut out and finish the job up without driving you all nuts with my schlemiels and schlemazels. All right, pull this up again. Like I said, when things are tight like this, you're going to need to move things around a little bit, but obviously we want to save real estate, right? So this is how you do it. So I'm pulling out this connector real quick. Where did I put my cable? Here it is. I'm using a black cable on a black board, so it basically, it disappears for the most part into the background. I was thinking about using red for the power and black for the audio path, but I was like, you know what? I'm just going to go all black this time and see what that looks like. I've got boards where they're green, boards where they're green and yellow, boards where they're black and red. So I figured this one, let's just do all black, right? Kind of like the New Zealand rugby team, the All Blacks. So there we go. Got that in, and we can go ahead and reattach the echo back down onto the board and tighten up this cable, make it nice, as they say. Make it nice. All right. So, like I said, I'm going to leave it here and then just keep going as I at my own pace. Should be done in another 5 or 10 minutes, and the thing will be ready to go. All right, so I'll see you in a bit. So we're done for now, anyway. We still need to get our second compressor board, but we've got it all wired up. We got it all zip tied. When the second compressor comes in, we'll just tie it all down with the big sort of loop guys to affix all the bundles to the board. But we're done, and it went very smoothly, no problems. We've got our little output interface here with the volumes. We've got our pedal fire, our power supply, flanger, input. It's all looking pretty good. So I guess I'm gonna go and test this thing out now and see how it sounds. But I'll see you guys once the second compressor comes in and we get that on the board. So again, thanks for watching, and we'll see you then.